How long did it take us to understand what's going on with a light bulb, a socket, and a switch? How much time?
That perhaps we're reaching an area of technology where they have some people who are and really don't need to know some of the things we're trying to teach. We have a ton of stuff, and I mean, think of all the knowledge we're trying to put into these kids. Is there a point where, like these graduates, really don't need to understand some of these things?
Hi, we were appreciative of the comment about technology getting in the way. We're wondering also if vocabulary gets in the way sometimes. We're really surprised by the difference in sophistication between use of language like charge and electron, but a total ineptness in terms of hooking wires together. I just want to concur with the question of relevance. What is the relevant thing that we should be concerned about? The content about circuitry, or whether they can figure out what's going on here experientially?
We, in our discussion here, talked about how teachers are perpetuating the type of learning that they had in their classrooms today, and how nice it would be if teachers had an opportunity to experience hands-on prior to working with their students in a hands-on situation.
Hi, I'm a physics teacher in Millis, Massachusetts. It seems silly to me that we're teaching bulbs and batteries to high school students, and the reason it does is that they should have already learned this sort of thing either in elementary school or as middle school students. And the problem is apparently that they're not learning things at those grade levels, and it would appear that the reason is that we're not using the right kinds of techniques. So if we're using a constructivist approach there and learning is effective, we can actually teach what we really would like to teach, namely somewhat more sophisticated concepts at the high school level. So what we need is a uniform program, K to 12, to be able to work constructively in a constructivist mode with students so that there's effective learning at all levels, and then we can really do what we want to do with high school students rather than doing what appears to me to be remedial work. And this requires a tremendous amount of retraining of teachers and teaching teachers at the elementary school level more science than they really know now. I think everybody recognizes that's a serious problem.
We do. We'd like to make a comment about the constructivist approach and the time commitment that's involved. Certainly, we agree that this will be helpful to some students, but we're wondering if we're watering down the material that we do teach and eliminating so much material from the curriculum by using the constructivist approach, that we will end up hurting our brighter kids that we want to know enough to be competitive throughout the world.
So let's take a look in their classrooms right now.
Okay, we took the pre-instruction quiz yesterday, and you made some predictions about which of those systems you felt would actually light the bulb.
So you're going to get a battery, a bulb, and a piece of wire, and we're going to figure out how to make it light.
Now, what's going to be very important through this whole process
is for you to write down everything that you do with that battery, bulb, and wire. Things that you think are silly and things that you think are not so silly, okay? Things that work and things that don't.
Because you learn a lot from the ones that don't work as well as the ones that do. Questions?
We're just tinkering around with ways to see which way the light bulb works.
Right.
No, just random putting things
Just
on.
random putting things together?
On the wire.
I did that.
Oh, we have tons of frustrated kids in this setting. I find it especially in the kids, higher level kids who have been very good and very successful at school, and now we change the rules on them. There aren't a set of formulas for them to memorize. There aren't, I'm not going to give them a set of lecture notes, but they just have to memorize all the words and know the vocabulary, and then they get an A on the test. And so they're very, very frustrated with the whole approach. The other frustration is I don't give answers. Your goal is you're trying to find 4 configurations that work.
I think the constructivist approach basically really asks one question: what kinds of ideas do children already bring upon which they're going to base their new learning? It's something, I guess, that it cannot be ignored because that is what we're being presented with. And as far as the time concerned, I suspect that we still have to make that decision about whether true understanding is more important than the coverage.
How long did it take us to understand what's going on with a light bulb, a socket, and a switch? How much time?
Say you teach us something, and some of us don't understand it, then we're already on something else. Isn't that bad? I mean, shouldn't we learn that whole section first? So if we take more time, it's better? Even if you don't get through the whole chapter or the whole book or whatever through the year.
With regard to teacher in-service programs, just as our students need hands-on learning, so do we as teachers. Many of us have come through the lecture and listen format and haven't had the opportunity to try a lot of these things ourselves. So I can say to in-service people, stop lecturing us and give us stuff to do.